that does not want to be part of the recording, they have to leave. Okie doke. With that said, today's agenda is posting of new RDL terms. With us today, we have Bård, which is going to present, and yeah, I guess I'll hand the word over to you, Bård.
Awesome. Thanks. Let me see. Can you see my screen now?
Yes.
We can.
Good. All right. Thank you, Fredrik. So today we will be talking about adding suggestions for new reference data, and particularly adding terms that are subclasses of other terms. So I try to create a small presentation just to set the scene. Then we will do some API calls, and finally just speak a bit about our thoughts for the future. So if we first look into the background, we would like to create an IMF attribute. And the IMF attribute that we would like to create is this manufactured by. And we can see that that is an attribute because it has a relation to, well, IMF attribute. One of the things that an attribute need is this IMF predicate that points to a reference term. In our case here, manufacturer. So what happens then if we don't find this reference term? Well, we need to be able to add it somehow. And the way we would like to add this term, this particular term, is that we would like to say that our manufacturer should be a subclass of something in IDO. And in this particular case, we have said that this should be a subclass of organization, IDO organization, or list organization as the namespace is. Do we need to be directly linked to IDO? No. We can kind of create a chain of subclass of relationships. So we can have manufacturer down here, company, and then company points, for instance, to list organization. So this is the subclass of chain that we will try to create. So creating now a new reference term should be linked directly or indirectly to IDO. And then we have these question marks before here because we don't know yet what domain ontology we would like to add these data to. So we need to create, or if we don't have, then we need to create a domain ontology that could capture this knowledge. So what we will create now is basically a company information ontology. And that is marked as an ontology by this type out ontology. And we will say that this particular ontology that imports IDO. What that means in our scenario here is that if we create new, when we create new RDF terms in our company information ontology, it can only link to terms in IDO. You cannot, you're not, and it has to link to an existing term. You are not allowed to create leaf nodes. So overall, IDO will be our upper ontology. There's the top nodes, and you are allowed to create leaf nodes. You are not allowed to create top nodes. Yeah, so that's it. That is described by this all imports. We can of course import other ontologies as well, but they should again be linked to IDO when then you create this hierarchy of ontologies. So now we should now we will create this this company information ontology, and we have an endpoint for that. I'll probably just have to. So now I just went to one of our environments. That's unfortunate. Let me just refresh this.
You forgot to check before you press.
Oh, right, yeah. Perhaps this. Check the boxes. Good. Orca solution. No thanks. All right. That was also a bit unfortunate. Let me just. That will take a bit of time. I don't know very well. My Bitwarden disappeared on me.
Yeah, no problem. No problem. We know these things. We are swapping tenants all the time, so we know.
Yeah, but I need my password manager. Where are you?
It's about half the work day now.
Here we are.
It's taking half a workday, yes, to get in.
And my, of course, my.
I need to see what that entails.
Let us see. It was my Webster account. Okay. Oh, is that possible? Huh. Let me try one more time with the correct password. All right. Sorry about that. Trying to log into different tenants. Okay, so now we have this domain ontology endpoints. So we would like to add a bit of information here. We have this change justification that we have for all new suggestions, name of an ontology and the description, and then a link to the ontology, the list of ontologies that you would like to be the upper ontologies for this particular domain ontology. So you can link it to multiple. Right now, we will just link it to IDO. And let's see, I have a snippet here. Like that. This IDO, adding IDO here, that is not something that is required. You will either way be linked to IDO. That just happens behind the scene, but to show that now, you can add it here as well. But that is a requirement. To add new reference terms, you need to be able to link them to IDO. Okay. All right. So now we basically created a new, let's call it an unversioned domain ontology. It is basically just a placeholder that we could link different terms to. Let's see how that works. So now we've created this structure over here. And what we would like now to do is to say that these new terms that I would like, company and manufacturer, we would like to say that these terms is defined by our newly created ontology. So basically the domain ontology we created, company information ontology, just works as a bucket for other terms to say, well, I'm defined here. It's the same that we see in RDFS, for instance. All the terms in the RDFS document points to itself or points to the document itself to say, this is where I'm defined. All right. So now let's say that we will create this company term and go back to our endpoints. And I have a new endpoint somewhere where I can add a subclass term to my newly created ontology. So let's see, just find this snippet. Okay, so I require some company information. The name is company. The description is taken from ISO 15926 Part 4. Legal entity, that is an institution created to conduct business. And then I link it to this ontology that we just created. And it is a subclass, should be a subclass of IDO part organization. Let's see what this gives us. There we are. So now we've created a new reference term, and I will grab this, and then I will move to see what we got. All right. So now we have a superclass here that is organization. We have the name company, subclass of organization. It is defined within this ontology. And here's the description. That's the information that we have now. This is just the information we have about this term at the moment. And then we go on to create our manufacturer. And that's, again, a new snippet up here. Let's see. I'll just copy paste. And now we can, this was my newly created company. So I just copy that and say that you should be a subclass of my newly created company. All right, this is the same, just we have manufacturer. That's basically an organization that produce something. We are still in the same ontology, but now we are a subclass of this company term that we created earlier on. And then we execute this. And we can go through this part here to just see how this works. Like that. Let us just get the URI correct. There we are. So now we're still in the same ontology. We have our manufacturer. It's a subclass of this term, which turns out to be our company. And then we can move on to organization, which is the IDO term that we are now linked to. Based on this, we can now go back and say, okay, the IMF attribute that we would like to create, we can now use CIO manufacturer as the predicate there. That's something we've shown before, so I'm not going to show that again. What I would like to talk a bit about is this company information, right? Because we could now use this IMF attribute as, for instance, my equipment manufactured by WebStep. And in this case, WebStep is now just a text string. It's a literal. And what I think as like we as an industry should be able to do is start posting. What I would like to do is basically create this ontology so that all the companies can use this company ontology to create their own IDs and their own information that can be used in different data interactions. But we need that information. Otherwise, we will start writing company names different, and somebody would have an ASA at the end, and others will not. And all these different literal ways we can spell our company names. We need to kind of share information in this way. And so that's why I, in this example, took terms that already exist in ISO 5096 and started to work with the domain ontology underneath IDO. But basically, let's start sharing some small pieces of information about companies or project IDs, something like that, that could be helpful. Basically, that should be available, is what I say. So other can retrieve it and know, all right, this is the company we talk about here.
So, I have a couple of questions.
Yeah, sure, please.
Your company with its now created reference ID.
Yeah.
Why aren't we just, because we will need this anyway, why aren't we using the RDS code or another known and have that kind of pre-made, because we know it's necessary for everyone? So that we don't kind of open up for people to create many company references or many types that represent company. So that's one thing. The other part is I'm even thinking that to be precise about companies, you may want to use the registration ID for that company in its chartered country. So the Brønnøysund register organizational numbers in Norway, for instance.
Absolutely, and I don't disagree with that at all. So we could, first of all, we could use the RDS number that we have, for instance, for manufacturer in our IMF attributes today, and that is probably, I would say, what we are going to do in a first step.
Very good.
But if we would like to add, if we don't find the reference data that we need, then we have to create them somehow.
Yeah, no, that's fine. I'm fully supportive of that.
Our suggestion now is, if we need to create something new, then we create it underneath IDO and not in ISO 5096.
Yeah.
And then my second point here was just that if we do a bit more and actually create this company information ontology, then we should start sharing that data. It's all the different companies' responsibility to make that information available, instead of using literals as the object for this IMF attribute.
And the reason I mentioned Brønnøysund is that they have APIs to actually, and they are quite into semantic representation there. So, it's an easy source to pull from. And there you would get then a lot of data for each one of those instances as well.
And perhaps they already have an ontology.
I think
I
they
think
do.
so.
Yes.
Yeah. So yeah, that would be great, basically.
Yeah.
Very good.
Okay, moving forward, we created this ontology, right? And I said that was a bucket for terms, because things are pointing towards it. So all that contains is basically, well, it says it's an ontology, and then it says what other ontologies do I import, and we use this import statement here as something. It is those ontologies that you are allowed, they will contain the classes and properties that you are allowed to link to. You cannot just go outside of that and say that I would link to something completely different. This is kind of one of the restrictions. And then you have the description and a label. And it's the different terms that actually said, well, I'm defined by this ontology. So this ontology, that will never grow in itself. It will just be there as a placeholder. And then we need something more. And now we're into that, what we think, how we think about ontologies going forward into the future, because we need something more so that companies can agree on this is the vocabulary that we actually have decided on to use when we send these data back and forth. So then we come over to versioned ontologies. Well, how will that look? First of all, I just added something here. I added that these terms, they will have a status. And these statuses, they will start out as draft because they are suggested. Then they will go through this approval process.
Yeah.
And they can be accepted or rejected back and forth. But for a term to be part of a versioned ontology, they must have reached the term must have reached the state of accepted. That's a criteria. You cannot have rejected terms in your versioned ontology, then it shouldn't be there. So this is all the information that is part of a versioned ontology. So instead of going through all this text, I've tried to represent this as a graph. So the first thing we have now is a versioned ontology, which should be an immutable collection. Once you have approved a versioned collection or versioned ontology, then it shouldn't change. So we have basically just taken the URI of the unversioned ontology, the one we created earlier, and said that, okay, you get year and month. This is your version number. And then it again states that this is an ontology. The key part here now is that this ontology that has an RDFS is defined by a collection. And this collection that contains the terms that are part of this versioned ontology. So if we now make a new, let's say that we weren't completely satisfied with the manufacturer term, we would like to replace that. And that is not a feature that is available yet, but we would like you to be able to edit existing terms and suggest new versions of them. And that, when that is approved, then you will have a replace relationship to the older term. And when we then create a new versioned ontology, the terms that are replaced will not be part of it. And the approved the terms that are not replaced, so that basically the ones that are now currently valid, not saying that the old ones weren't valid at the time, but at this moment now, somewhere in the future, this other set of terms are valid and approved. They will be suggested for the next version of this versioned ontology. And in this way, we can create, for instance, yearly updated versioned ontologies that will be immutable. And we'll have some extra information as well. You will have imports. You have to now import not the general ontology, but actually you have to import versioned ontologies as well, because you have to know what terms are now actually linking to. And this means if you take one of the upper ontologies and change it, well, that can have a ripple effect. Then you also have perhaps to update or take that into account the next time you update your lower level ontologies, if you would like that to be related to a newer version, one of the upper ontologies. And it will also have this information about where was I derived from? Well, that is the unversioned ontology. And you will get, when we get into this, start to change things, and the next version you will have, okay, I replace this previous version and stuff like that. These versioned ontologies, that is what I think we should be using when we state that this is our vocabulary when we will exchange these data now for this contract. And then for the next contract, there might become a new versioned ontology may be available, and then that is what we would use, right? So you can this information will be available to you. Yeah, forever, I guess.
Question again.
Sure.
You have your had member relationship. Is that just a misspelling for has member or?
That is the Provo. This is Provo ontology, and that's not the one we should be using. But they like to use this, had
Okay,
tense of the verb, because at the time when we created the collection, it had these members.
okay, fine.
But I cannot say that it still has them. So yeah, that is in that ontology. It's how they have done it.
One other thing, you said that if you change a term, they will no longer be part of the new version of the ontology. But I guess we will need to deal with deprecated and replaced to be able to apply a new version to older data sets.
All these terms will be related to all, like deprecated and rejected, approved, draft. All these terms will still be linked to the unversioned ontology. And then when you create something new, it will first enter here. You might add a new suggestion to a term. It may be approved so that an existing term that is part of a version ontology is replaced. Then the next version ontology will suggest that this is now removed from this version. It will still be in the old version, but it will not be in the new version.
Okay, but to tell that it replaces something, you would still need the reference. So, but you can refer back to the older version then. So, okay, fine.
We have that in the term itself is linked to a bit of metadata, so where, for instance, the status is, and there you will also get that chain of events that this term replaces another term, so that you can follow that link of replacements. Well, that's at least the idea. Yeah.
Yeah. Thanks.
So, and that's why we don't actually change a term. We create a new one.
Yeah.
Yeah.
And say that this replaces this old term. So the old term will always be there, and you can still use it if it has status rejected. But of course, that's not recommended, right?
Bob, I'll get a question as well.
Oh, yeah, sure.
Yeah, but I guess you already answered it. All this will be traceable, so you'll have the older versions, and you can go back and see, because there might be instances where we will need to know the history of the versions.
And all that should be traceable, and all the versions themselves, like that, you should be able to download all the versions as an RDF representation, for instance. It's not something that is lost. So that is something that we should be able to count on to make an agreement between parties that this is the vocabulary that we use.
Okay, thanks. Super.
Of course, this is a bit down the line, but I wanted to kind of use this opportunity to share our thoughts, so that people have time to give feedback and come with input. Yeah. But the first step is on the way. We can create those buckets, those unversioned ontologies, and add new terms to them. So that's the first step on the way. Of course, also at the moment, we can only add subclass of relations. This will expand with time, so that you can create individuals, sub-properties, and all restrictions. So that's all in the, on the drawing board.
I see we're 2 minutes over. Is there any more questions or comments?
It was good. It was good. So, but the half an hour is too short, it seems like.
Yeah.
Very useful. Thanks a lot.
Yes.
Thank you. And just reach out to us if you have any questions or would like to give some feedback offline. That's yeah.
Very good.
Look,
Have a beautiful weekend.
thanks and thank you both for the presentation.
No worries. Thank you.
Thank you all and have a nice break and 17th of May.
Likewise.
And
Have a nice time, May.
bye-bye.
Bye.
Bye.
Veldig bra, Bård.
Ja, takk. Nå trenger jeg noe å drikke.
Ja. Nei, men det var godt fortalt. Det var jo en teknisk gjennomføring, men jeg også henger med, og det er bra.
Ja, men da synes jeg vi har, ikke det, jeg tror du forstår mer av det tekniske nå enn det du gir deg selv kred for. Så men det er veldig bra hvis vi klarer å få diskusjonen litt ned på et folkelig nivå. Det tror jeg er lurt.
Ja. Nei, men det er kjempebra.
Thank you.
God 17. mai.
God 17. mai, ja. Kos deg. Masse is.
Ja, ha det.
Ha det.